start Unit 1 now. Before going to the Unit 1 reinforcement learning, we need to know some definitions of AI, ML, and reinforcement learning, where AI refers to the development of computer science that can perform tasks that typically require human intelligence, such as learning, problem solving, and decision making, where ML is a subset of AI, and AI is a subset of AI that involves training algorithms to learn from data and make predictions or decisions without being explicitly programmed, where DL and RL are deep learning and reinforcement learning are the subsets of ML, where RL is type of ML where an agent learns to take actions to maximize a reward or achieve a goal through trial and error methods, where deep learning is also a subset of ML that uses neural networks with multiple layers to analyze data inspired by the structure and functions of the human brain. Here DL is not necessary, but still I am giving you the definition only. So you can see here RL, reinforcement learning, is a process of encouraging and pattern of behavior. It involves the development of computer systems and algorithms that can perform tasks typically require human intelligence. The tasks involve virtual perception, speech recognition, decision making, and problem solving, and language understanding. So RL enables machines to learn, understand natural language, and make their decisions based on their input they have analyzed. And these systems can analyze data, recognize patterns, and make predictions automatically given to the data provided for it. So AI, you can see the applications of AI here. Artificial intelligence has numerous applications such as including healthcare, finance, transportation, manufacturing, entertainment, and some many more applications it has. So AI comprises a broad range of techniques approaches including machine learning, neural networks, and natural language processing, computer vision, expert systems, and robotics. So when we discuss about ML, machine learning is a crucial component of AI where algorithms are designed to learn. As I said you, where algorithms are designed to learn in ML and make predictions on their own make their decisions based on the data patterns given to it. There are different types of machine learning techniques including supervised learning, unsupervised learning. As you all learn in machine learning subject, there are types like supervised learning, unsupervised learning, and also, oh sorry, let me take you to the page. Okay, then supervised learning. Supervised learning model is trained on labeled data where input and the desired output are provided. The model learns to map inputs to outputs, enabling it to make predictions on new unseen data. Like we are giving the model like labeled data, matlab cat picture with cat label. We are providing all the labeled data to the model. Then we call as supervised learning. Here in unsupervised learning, we are not giving any labeled data. We are just simply giving the unlabeled data. So the machines are able to learn on unlabeled data. So in unsupervised learning, the model learns patterns and structures in unlabeled data without any specific output label. So it learns itself by discovering new hidden patterns, groups similar objects like into clusters. It groups all the similar objects or data into clusters and find new hidden patterns. So these are few applications. Customer and market segmentation is an application of unsupervised learning. Customer and market segmentation, the unsupervised model, it groups the people, similar people having similar traits, and it clusters all the people and collects the data, and it creates customer personalizations, and it is more helpful for efficient marketing. So let's move on to the machine learning. Reinforcement learning, reinforcement learning, the model learns through interactions with the environment, description of a PT or personal description of a character. So what actually reinforcement learning says you is, it is a type of ML where an agent learns to take actions to maximize a reward or achieve a goal through trial and error methods. So here you can see um, it interacts with the environment, receiving feedback in the form of rewards or penalties. It explores different actions and learns to maximize the cumulative reward over the time. So its main goal is to maximize the cumulative rewards by receiving, by choosing the correct action. Sorry. Reinforcement learning is a type of machine learning method where an intelligent agent interacts with the environment same and learns to act within that. So it learns. It doesn't have any data about the environment or anything. It just interacts with the environment and learns through it using trial and error method. So here's an example where a robotic dog learns the movement of its arms. So the dog is not trained or pre-programmed. It learns itself from its own experience by interacting with the environment without any human intervention. So, ML is the development of computer systems that are able to learn and adapt by using algorithms and statistical models. So, to draw graphs or take inferences from patterns in the data, we use ML for developing the computer systems. So here you can see uh, it's an agent. Here you can see it is an agent, and the agent is in the current state S. Let us think it is a current state in S, and it decides to take an action A in the environment, interacting with the environment. So the interpreter here is an interpreter which checks whether the agent is choosing the right action or wrong action. Whether the agent chooses, if the agent chooses the correct action, it is the interpreter is giving a reward to agent. And if the agent is not choosing the correct action or chooses the wrong action, then it will be getting the reward. So let's next move on. Here you can see agent are trained on reward and punishment mechanism. I said you right. Human error trial method means punishment reward mechanism. It's also like uh, trial error method. So where the agent is rewarded for correct moves and punished for the wrong ones. So in doing that, agent can learn on its own by maximizing the right actions and minimizing the wrong actions. So next, move on to the examples of RL. Examples of RL. The toddler is sitting on the floor, makes an action, tries to stand up, and gets reward after this. The toddler doesn't know how to walk, and he learns by trial and error method. As well, no toddler is a small baby, he don't know how to walk. So he tries by standing up and then moves forward. And so by moving forward, he may get a reward like a chocolate or something else. It's the basic trial error method which is used in RL. So, and also robotics, the ultimate goal of reinforcement learning is to train robots to learn and adapt and reproduce tasks with dynamically changing constraints based on exploration and autonomous learning. So the robots or the agents explore overall the environment and learn through what learn through the previous decisions or actions it takes. So some restaurants also use the robots and to deliver the food to certain tables or some it serves the food. In common settings, automated robots have been used thus far to assemble the products and to inspect for the defects, to deliver goods, and to travel long and short distances, grasp and handle objects, to handle the objects of different shapes. It can handle the objects, and then we continue to test robotic abilities. New features are being introduced to expand their potential. Uh, Autonomous vehicles (RL) can be used to train self-driving cars, drones, or other autonomous vehicles. RL algorithms enables these vehicles to learn how to navigate roads, make decisions, and respond to different traffic scenarios by using the sensors. RL is also used in game playing to create intelligent game agents or opponents in video games. Agents can learn optimal strategies to win and maximize the rewards. So it is also providing a challenging gaming experience. So the terms used in RL are agent, environment, and action, state, reward, policy, value, and Q value. So let's discuss one by one. Agent, an entity that can perceive, explore the environment, and act upon. Agent is nothing but a robot or a machine or the system that is trying to interact with the environment and learn about the environment, what actions need to be taken or what movement be taken. It chooses the hit and trial error method process to gain more cumulative rewards. Environment, the situation in which an agent is present or surrounded by an RL. We can assume that an environment is stochastic means uncertain or random, where the environment is random. We cannot assume the environment, or we can, the agent can't know the environment, how it is. So, which means it is a random in nature. A random maze football ground, an agent needs to explore the environment. He doesn't actually know about what kind of environment it is. He needs to explore all at once. Actions. Actions are nothing but actions are the most taken by the agent within the environment state. So state defines the current situational status of the agent, where the current position it is, and which affects the agent's decision making process. And then we talk about reward, where reward is a feedback signal received by the agent after taking a certain action, which and it is used to evaluate the action of the agent. And let's now discuss about the policy. Policy is nothing but a plan or a strategy or a mapping that determines the action of the agent takes in the given state. Why? It is based on, it chooses based on the previous action it has taken or the current position where it is. And then when we talk about the value and Q value, they play a major important role in RL. Value function is denoted as U of S, which is used to represent the expected cumulative reward an agent can obtain by starting from a particular state S and following a policy phi. In other words, it estimates the value of being in a specific state, whereas Q value or Q value function represents the expected cumulative reward an agent can obtain by starting from a particular state S, taking a specific action A, and following a policy phi. It estimates the value of taking a particular action in a specific state. In short, we can say that uh, value estimates the expected cumulative reward of being in a state, whereas Q value estimates the expected cumulative reward of taking a specific action in a specific state. Value is expected to receive a long-term reward rather than a short-term reward, but in Q value, it is more similar to the value, but it takes additional parameters such as current action. It also involves a current action. And then both are useful. Q values are used to iteratively improve the performance behavior of the learning agent. And that's it for this video. Thank you.